Hi everyone and welcome back to physics. This is Mrs. Hutchinson and today we're going to continue our discussion on tools of physics. More explicitly, we're going to talk about factor label, or what I think we've discussed in terms of chemistry, we talked about dimensional analysis. So if you didn't like to convert from one unit to another in chemistry, well, you are definitely not going to like physics, because that is pretty much what we do quite a bit. So what I wanted to do is take a deep breath and realize, okay, we can do this. It's not so bad. So let's hop to it. There is a very common need to change units in physics problems. Lots of times we give you values in meters and we actually need you to put them into kilometers, or we'll give you values in grams and you need to put them into kilograms. So we're going to be using dimensional analysis and our T-charts, remember we talked about those a lot in chemistry, to convert from one factor to another. It's pretty simple. Let's review it a little bit. So for example, we know that 1 minute is equal to 60 seconds. So the fraction that we're talking about is 60 seconds over 1 minute. If we multiply a quantity like 2 minutes by this fraction, we're essentially multiplying it by 1, because 60 seconds, that's a different unit than 1 minute. Minutes and seconds are different units. So let's take our given of 2 minutes, make our T-chart. We're going to place our 1 minute down here, our 60 seconds up top, and many of you are probably like, I can do that in my head. I know, I'm just refreshing your memory. We multiply straight across and we get 120 seconds. Remember our T-chart? Remember our units need to cancel out? Whatever is given must cancel out with the unit that we place in the bottom right. Okay, that should be much of a review for us. So now we've got 4 different types of conversions that we can possibly encounter here in physics. The first one would be pretty simple, a metric to a metric conversion. So if you don't have your reference tables out, please make sure that you get them out, because we're going to be using our prefixes for powers of 10 reference table. So let's take a look at what we're given here. We've got 295 centimeters and we want to convert that to meters. So if we take a look at our conversion factor here, we would make it and it would say that we've got 1 centimeter is equal to 10 to the negative 2 meters. It's a simple one-step conversion. All we did was we created our conversion factor from our reference table. So then we'll take our given, write that down, 295 centimeters. Place our centimeters down here, place our meters up top. Looking at our conversion factor, the 1 is in front of the centimeters, 10 to the negative 2 is in front of the meters. Our centimeters crosses off, and we multiply straight across, and we get 2.95 meters. And of course that makes sense, because of the fact that our meters unit is much larger than that of our centimeter unit. Here, we're converting from one metric unit to another, so this is a 2-step process. Remember, when we go from one metric unit, one prefix unit to another prefix unit, we actually have to have 2 different conversion factors. So I'm actually going to change this here. So we've got 8,362 milliliters, and we want to convert it to deciliters. Okay. Convert that to deciliters. Not really sure why I started off the way I did. So first we have to have a conversion factor to get us from milliliters to liters. So if we take a look up here, we've got milli and we've got deci. Wow, my boxes have gotten progressively worse, but that is okay. So our conversion factor for milliliters is 1 milliliter equals 10 to the negative 3rd liters. And for deciliters, 1 deciliter is equal to 10 to the negative 1 liters. Okay, so those conversion factors shouldn't be so hard for us to make. Now what we're going to do is we'll take our given, we'll make our t-chart. So 8, 3, let's make a line, 6.2 milliliters. There's our t-chart. We're going to use our first conversion factor to get us from milli to liters. We'll put our 1 milliliter down here so our milliliters can cancel out. 10 to the negative 3 liters on top. We'll then use our second conversion factor. Liters is now the unit that's on top, so liters has to go on the bottom. So 10 to the negative 1 liters, 1 deciliter on top, liters can cancel out, and we simply multiply straight across. So 8362 times 10 to the negative third, and we divide that by 10 to the negative 1, and we get our final answer of 83.62 deciliters. That should all be a review from chemistry when we're going from one metric unit to another metric unit, one prefixed metric unit to another prefixed metric unit. If you struggle with that, make sure that you watch the video again. We also have another type of conversion. So we're going from a metric to a non-metric conversion. In order to do this, I would have to give you the conversion factor that you're going to be using. For example, I would have to give you a sheet much like this. Okay. So convert 100 yards into meters. Okay, so let's take a look. We could either use this conversion factor or we could use that conversion factor. I'm just going to use the first one since it happens to be the first one that I saw. So our conversion factor would be 1 meter equals 1.094 yards. If you use the second one, you might get a slightly different answer because they are in fact numbers that have been rounded off a little bit. So we'll write our given. That was a silly 0. 100 yards. And we'll make our t-chart. Let's use our conversion factor here, 1.094 yards, 1 meter. Our yards has to cancel off. We multiply straight across. So we would get 100 times 1 divided by 1.094. When we do that, we would get 91.4 meters. Yay, that's our first one. Next, if we take a look at the next one, we've got, we're converting from kilograms to pounds. So we've got mass over here. Our kilogram is equal to 2.21 pounds. So we've got 1 kilogram equals 2.21 pounds. So let's take a look at this conversion factor. We've got 75.0 kilograms. 1 kilogram, 2.21 pounds. Let's multiply straight across, and we would get 165.75 pounds. Not so bad. Again, all of this should really be a review from chemistry. So far, so good. Let's take a look at the next one. Let's convert units of area or volume. So they deal with squared or cubed units. So this is where it's a little different from what we have done in chemistry. All you have to do is find your conversion factor. So we're going from square feet to square meters. So that means we want a conversion that gets us from feet to meters. So there would be our conversion factor that we're going to use. So 1 foot equals 0.304 meters. To make a square foot, you're going to square that side. To make a square meter, you're going to square the other side. So that means you'll distribute it. So our new conversion factor would be 1 square foot, because when we distribute our 2, 1 times 1 is 1. 0.304, when that is squared, it comes out to 0.092416 meters squared. So this is now our new conversion factor that we're going to use. So all we did was just take our normal conversion factor and square it to get it into our unit of area. We'll now take our given, 4765 square feet, and we'll use our conversion factor that we just created of 1 square foot, 0.092416 meters squared. Multiplying straight across, we would get our final answer of 440.36 square meters. That's not so bad. Okay, it's just the same idea of what we have been doing. So now let's move on to the next one. And we're converting from cubic centimeters, and we're going to make this cubic decimeters. So we're going to do the same thing that we have been doing. So now we're converting from one cubic metric unit to another cubic metric unit. So take out your reference tables, and the conversion factor to go from centimeters to meters would be 1 centimeter equals 10 to the negative 2 meters. Decimeters, 1 decimeter equals 10 to the negative 1 meters. Much like we did for our unit of area, we're going to cube both sides, I should say, because we're now in volume. So cubing all sides of the equation. So our centimeters become 1 cubic centimeter is equal to negative 2 raised to the power of 3 actually gives us 10 to the negative 6 meters. And decimeters, 1 cubic decimeter is equal to 10 to the negative 3rd meters cubed. Forgot to write the cubed. So we now have our 2 new units here, or 2 new conversion factors, I should say. So now, let's go ahead and let's write our given of 3295 centimeters cubed. There we go. We've got our 1 centimeter cubed here, 10 to the negative 6 meters cubed there. Centimeters cubed crosses out. We've got our 10 to the negative 3 meters cubed here. Meters cubed crosses out. Our decimeter cubed goes on top. We multiply straight across. And in multiplying straight across, we're going to have 3295 times 10 to the negative 6 divided by 10 to the negative 3. That's going to give us a final answer of, which I'm going to have to write up here, 3.295 cubic decimeters. Okay? That's how you would convert a unit of area or a unit of volume. Let's take a look at our last type of conversion, and our last type of conversion deals with derived units. So derived units, remember, they deal with base units and different ways to manipulate those base units. So the difference here is that we have more than one unit we actually have to worry about now. So convert 1895 miles per hour to kilometers per minute. So what does that mean? That means that we are actually converting miles into kilometers and then hours into minutes. Units that are simple, that gets us, say, from hours to minutes or days to hours or things like that, you need to know those. That I'm not going to give you. So let's take a look at our miles and kilometers one. We do in fact have a conversion factor here that gets us from kilometers directly into miles, or from miles directly into kilometers. So that's one conversion factor that we're going to be using. The other conversion factor would be, well, how many minutes in an hour? 60 minutes equals 1 hour. So we're going to be using all of those. Now let me show you how this is going to work. So we have 1895 miles per, we still have our T-chart, per 1 hour. So the unit that's right next to the number goes on top, and then the per means 1 per 1 of whatever. So now let's just focus on our miles here. So if we're converting from miles into kilometers, let's use our conversion factor. So we've got 0.621 miles, that'll cross off, to 1 kilometer. So now our top unit is what we're looking for, is in kilometers. Now our bottom unit, hours, in order to cross off hours, we have to write hours on the top here. 1 hour, and we put 60 minutes on the bottom. If we take a look at our new conversions, our new factors, or units I should say, it's kilometers per minute, kilometers over minute, which is exactly what we're looking for. So what we're going to do is we're going to plug this into our calculator, and we're going to see what it comes out to. And your calculator should come out and say that we have 50.86 kilometers per hour. Let's try the next one. So we've got to convert 65 miles per hour into meters per second. So let's just declutter this a little bit. So the first thing that we're going to look at is we're going from miles into meters, and then from there the other conversion we're going to do is hours to seconds. So, can we get directly from miles to meters? Yep. There's one conversion factor that we can use to get from miles into meters. To get from hours to seconds, many of you probably already know that 1 hour is equal to 60 minutes, and then 1 minute is equal to 60 seconds. So you could do two conversion factors, or you could say 1 hour is 3,600 seconds. I'm going to use the second one. Either or. So now let's take a look at what we have given. We've got our 65 miles per our 1 hour. So now let's convert miles to meters. So 1 mile equals 1609 meters. Miles is going to cross off. Now we're into our top unit, our correct top unit that we're looking for, meters. Now hours has to cross off, so we put hours on the top. We'll do 3,600 seconds on the bottom. So now if we look, our units are in fact meters per second. We're going to multiply straight across and then divide. So 65 times 1609 divided by 3,600. And we would get 29.05 meters per second. Okay, not too bad, pretty simple. So let's take a look at the next part. Guided practice. I want you to work on the next couple of worksheets. There are a bunch of different worksheets. The only way that you're going to get better at this is if you practice. Practice, practice, practice. Me going through all of that isn't going to necessarily help you in terms of understanding. What I want you to do is I want you to practice first, then I'm going to come in and I'm going to help you after that if you have questions. So I want you to work on this worksheet, and I want you to work on your independent practice for factor label. And yes, there is a third one. And by third one, I mean the other side of this worksheet. So make sure that you do both sides of the independent practice worksheet. But there is yet another one where we're going to be dealing with more dimensional analysis. So again, you're going to be working on 3 worksheets. You're going to work on our guided practice for factor label, so that worksheet. You're going to also work on the independent practice, both sides. And then you're also going to work on our more dimensional analysis worksheet. So we've got 3 worksheets for you to work on. So make sure that you get them all done. That's quite a bit of work. But use this video to help you if you get stuck. And I'll see you with our next video.